Hello, everyone. A little background about why I chose this topic. Back in the day, before I started the nursing program, I actually was able to read for pleasure, and somehow I stumbled upon the topic of maple syrup urine disease, which I thought was fictitious. But now I know, just as there really is such a thing as blueberry muffin rash, due to the red and purple cutaneous skin discoloration once associated with a congenital virus, or, even more familiar, a strawberry hemangioma. And this is actually my nephew. I learned it's not unusual for medical professionals to be inspired by some of our most tasty foods in the name of science. On that account, I present to you maple syrup urine disease. The question that first arises is, why is it called maple syrup urine disease? And the answer lies in what is understood as the first clinical sign of the disease. Should the individual be afflicted with the disease by genetic predisposition, approximately 12 hours after birth, the smell of burnt sugar coming from the neonate's urine can be detected. The disease is characterized by 5 clinical subtypes as well, and, if left untreated, is capable of progressive neurodegeneration, eventually leading to death. In order to appreciate the disease and find its causes and treatments, we must begin by first understanding what occurs at the biochemical level with amino acid catabolism. Specifically, what separates a person like you and I from one with maple syrup urine disease. As evidenced by the structure in the corner, up at the top there, amino acids are made up of carbon, hydrogen, oxygen, and nitrogen, or a carboxyl group and an amino group. The body can synthesize some amino acids, which are the structural elements of protein, and others we must get from our diet. With respect to maple syrup urine disease, 3 essential amino acids that we must get from our diet, like I mentioned, and you'd probably find that more, as you're probably aware, with meat and dairy products, are isoleucine, leucine, and valine. Unlike other amino acids, which are metabolized by the liver, these amino acids are metabolized by the peripheral tissues, specifically muscle. Amino acids begin their catabolic activity with transamination, which removes the amino group, the NH2, and leaves us with a carbon skeleton, which then, through a series of additional reactions, will lead us to end products that are involved in major metabolic pathways. We break the amino acids into 2 groups, both the glucogenic and ketogenic. The glucogenic are degraded to pyruvate, or one of the 4,5 carbon intermediates, meaning the amino acid can be converted to net glucose for the kidney or liver via gluconeogenesis, whereas ketogenic results in ketone bodies for lipid synthesis in the brain, hence the name. After the initial transamination, which results in the subsequent alpha-keto acids, oxidative decarboxylation occurs with a very specific and central enzyme complex that is deficient in those with maple syrup urine disease, which is known as the branched chain alpha-keto acid dehydrogenase. Although I'm grossly simplifying the process, oxidative decarboxylation, which is probably most familiar to us from our understanding of the citric acid cycle, is when electrons are removed and transferred to an electron acceptor, followed by the production of CO2. In people like you and I, a few other reactions would occur with the help of cofactors and specific enzymes, leading to the precursors for other aforementioned metabolic cycles. But now, instead, there is an accumulation of not only the 3 amino acids, but also their corresponding branched chain alpha-keto acids. Of course, the combined excessive amino acids and intermediates are excreted in the urine and, as suspected, are responsible for the maple syrup odor. But the smell of sweet syrup is not the only part of the clinical picture for those with such a unique and rare diagnosis. Chronic amino acid imbalances present anatomical and physiological symptoms starting 2 or 3 days post-birth, with ketones present in the urine, general irritability, and poor feeding. This is followed by deepening encephalopathy, which is a broad term that encompasses decline in normal cognitive functions and attributed to the accumulation of leucine. At this time, one might also observe the infant showing signs of lethargy, which is intense fatigue, apnea, cessation of breathing, and as evidenced by the photo to your right, opisthottonos, which is a rigid spasm of the body characterized by a back that's rather hyperextended, if you will. About 7 to 10 days later, if not treated, respiratory failure and coma may commence. Of particular interest to me, in terms of the research on aging maple syrup urine disease patients, are those whom we will see in later slides who adhere strictly to their treatment but still struggle with neurotoxicity issues, specifically related to neurotransmitter deficiencies related to the excess leucine. There is some evidence that the keto acid derivative of leucine reverses the direction of nitrogen flow and overall deprives the brain of glutamate, which is the body's most prominent neurotransmitter and is used by the brain to synthesize GABA, impacting both mood and cognition. This proposes a potential pathway for future research on psychiatric correlations with maple syrup urine disease, another area of interest for me. The famous Dr. Carl Sagan once said about research, somewhere, something incredible is waiting to be known. As such, I'd like to move now to some research specific to areas of my discussion on the biochemical aspects of the disease. At Acer Therapeutics in Cambridge, Massachusetts, they have a mission of focusing their pharmaceutical efforts on modifying existing formulations for rare diseases with a significant medical need. As such, their current clinical program, Acer 001, is focused on sodium phenylbutyrate. And I should also mention that that's understood to be NAPBA, which in vivo, to test on living organisms, has shown promise in preventing phosphorylation, which is a regulatory function for proteins. Specifically, E1 alpha is one of the subunits of the BCKD enzyme complex that I mentioned, and therefore it chemically inhibits the mutated enzyme of those with maple syrup urine disease from further activity and is proven, or not proven yet, but may have a therapeutic effect. The exact mechanism for the reduction in the resulting branched chain amino acids in those with maple syrup disease does remain unclear, but it'll be interesting to see how that evolves. I just want to say thank you for listening, and that would complete my project on maple syrup urine disease.